next our point of discussion is frame of reference. So what is a frame of reference? It is a set of coordinates which is fixed with respect to which the position of body in motion is measured. It is what a set of coordinates. You know that these are three mutually perpendicular axes, x, y and z. This is called what? Coordinate system. We call it what? Coordinate system having three axes, x, y and z. With respect to this coordinate system, we will find out the position of a body. Position of the body, you know that in motion when the body will change its position from one point to another point, to that position we have to find out, and at what time, what is the time to be taken by the body to move from one point to another point, that is also be measured with the help of this frame of reference. You know that the rest and motion, those are relative to each other. Suppose one bus is moving. The driver of the bus is in motion with respect to the person who is standing outside the road, and the driver of the bus is in rest according to the person sitting inside the bus. So with respect to the frame of reference, when the person is standing outside the bus or alongside the road, according to that frame of reference, the bus driver is in motion. But according to the frame reference of the passenger who is sitting inside the bus, according to that passenger, the driver is in rest. So that is the motion of the person or position of the person that can be measured with the help of frame of reference. The frame of reference is what? That is what? A coordinate system, and coordinate mean x, y, z axis. Clear? So here this is x axis, so you know that this is our negative x axis, we denoted with x dash, and this is y dash, and this is what? Z dash. These are the negative x axis. And in this coordinate system, here we have xy plane, then yz plane and xz plane. These are the three planes which will make a coordinate system. This is xy plane. The two sides of the coordinate system will form plane, that is xy plane. This is what? Xz plane. This is what? Xz plane. This is zx plane. This is zy, and this is zx plane. So there are three planes which together make a coordinate system. So with the help of coordinate system, we can define the motion. We can define motion. Mean if coordinate of body changes with time, the body is in motion. And rest we can define that if coordinates of body does not change with time, is in rest. So these 2 points we will discuss one by one when we will discuss about the motion in 1 dimension, motion in 2 dimension and motion in 3 dimension. If the coordinate will change, the body is said to be in motion, and if the coordinate does not change, the body is said to be in rest. Now we will discuss motion in 1 dimension. Motion in 1 dimension mean body is said to be in one dimension when only one of three coordinates used to specify the position of the body. Position of body with respect to time. Let us suppose this is the starting point of the motion of the body. This point is also known as a reference point, and body is moving, suppose, along x-axis. This body can also move along y-axis. This body can also move along z-axis. So only one coordinate of the coordinate system is used to specify the position of the body. Suppose at any instant of time t, the position of the body is at point P. So this distance from the O to P is taken to be let x. So only this x coordinate, x distance from this origin, from this reference point, specify the position of this body at this t time. Suppose at t dash time the body is reached at point P dash. Then its distance from the origin is x dash. The body has changed its position from P to P dash. So we can say that body is in motion along one dimension, along one of the axes. This motion is also known as linear or rectilinear motion. Linear or rectilinear motion, that is along one of the direction. Similarly, body can also move along y-axis. So this y-axis can be used to specify the coordinate of this y-axis used to specify the position of the body with respect to time. So suppose body lies at point P, so we can say that the body is at rest, but body is changing its position from P to P dash. Its coordinate got changed. Earlier its coordinates was x, then changes to x dash. So body is said to have changed its coordinates. The body is said to be in a one-dimensional motion. Clear? Second is motion in two dimension. Mean two coordinates used to specify the position of the body. Specify the position of body. Two coordinates mean here we have x-axis and y-axis. Mean motion in plane. We can say that motion in a plane. Which one we are taking? xy plane. Suppose at any instant of time the position of the body is at P point. So according to this P, the distance of this P from origin is x, and along y-axis it is y. So we can say that pxy is the coordinate of this P point, which is used to specify the position of this body. Now this at P point the position of the body is rest. The body is in rest state. Let at a time t dash the body has changed its position to P dash. So according to this the coordinate change, let it be x dash, and according to this point the coordinate be y dash. So we can write here x dash and y dash is the coordinates. Those are used to specify the position. And this body, let the body change its position. This is the path of the body. Whatever this path, it may be straight path or maybe curved path. So body will change its position from P to P dash. The body is said to move in two-dimensional motion. An example of this motion mean that ant on the floor. That is the two-dimensional motion. Okay, that second we can take that motion of the planets, motion of planets, motion of the earth around the sun, that is two-dimensional motion. And car moving in zigzag, car moving in zigzag, that is the two-dimensional motion. In one-dimensional motion we can say that examples are, that is freely falling bodies. Freely falling bodies are undergoing two-dimensional motion, one-dimensional motion, rectilinear motion. One more we can write that motion of car in straight line. Motion of car in straight line. These are the example of one-dimensional motion. These are the example of two-dimensional motion. And the third is motion in three dimension. When three coordinates are used to specify the position of the body with respect to time is called three-dimensional motion. Suppose this is our coordinate system x, y, z. So according to this three-dimensional motion, the body is moving. Example, kite flying on a windy day. That is the motion of the kite. And you know that motion of the kite, that is randomly, it may be along x-axis, it may be along y-axis, it may be along z-axis. This is x-axis, this is y-axis, this is z-axis. Z-axis is toward you. We can say this is the vertical axis. This is z-axis. Okay, x-axis, this is y-axis, this is a z-axis. Here on the paper we cannot represent it. That is on the paper there is only two-dimensional picture we can show. But actually three-dimensional is vertical motion. Okay, that is the kite flying on a windy day. That is what three-dimensional motion. Similarly, we can say the motion of the aeroplane. Motion of aeroplane. It is what? Three-dimensional motion. Motion of the aeroplane is a three-dimensional motion. So, three coordinates are used to specify the position of the body with respect to time. Suppose here P is the position of the body at any instant of time t. So x, y, z coordinates are used to specify. According to this, here we have x, according to this we have y, and according to this we have what? Z. And suppose body has changed its position from P to P dash, x dash, y dash, and z dash with its coordinates. So these are the three coordinates which are used to specify the three-dimensional motion.